Let's go ahead and talk about the problem of the day. Be sure to answer the questions I ask out loud and think about how your work is the same or different from what we talk about together. Okay, so first question, how did you represent and solve this problem? Say it out loud. Right. We could draw a picture of a square and label each side 1/8. On a square, we know all the sides are the same length. We could also write a number sentence, right? 1/8 plus 1/8 plus 1/8 plus 1/8 equals P, or the perimeter. Okay. Why did you write that number sentence? Say it out loud. Yeah. In the problem, we're being asked to find the perimeter. And we know that we find the perimeter by adding up the total of all the sides. So each side of the square is 1/8, and there's 4 sides, so we need 1/8 plus 1/8 plus 1/8 plus 1/8. How could we represent this equation with a visual model? Say it out loud. Okay, so yeah, we could draw one hole and partition it into eighths, since that is the unit fraction that we're working with. So I'm going to go ahead and draw a hole here. Great. Each part is 1/8. Okay, and what would I do now to go ahead and represent the problem? Say it out loud. Yeah, I could just shade 4 1/8 pieces to represent each side of the square. Okay, great. And what if I have fraction tiles? What could I do there? Yeah, I could just use 4 1/8 fraction tiles also, couldn't I? One for each side. They both work. Okay, how would I solve now? Say it out loud. Yeah, we're just going to count up how many eighths we have. Count with me. 1/8, 2/8, 3/8, 4/8. Same thing with the fraction tiles. Count with me again. 1/8, 2/8, 3/8, 4/8. Great. We could also think of this as just adding up the numerators. When we add up the numerators, we get 4/8. So what do you notice happened to the numerator and the denominator when we added? Say it out loud. Yeah, the numerator changed, didn't it? But the denominator stayed the same. I'm going to label that. We have same denominator, and why did that numerator change? Say it out loud. Yeah, that numerator changed because it's telling us now the total number of parts that we have. Okay, so why does this make sense? Why would it be the case that the numerator would change, but the denominator would not when we're adding a fraction with the same denominator? Say it out loud. Right. When we add the numerator, it changes because we're adding the parts of each fraction. When we add the denominator, right, that stays the same because the number of parts in one whole doesn't change. You could also think of this as the size of the whole doesn't change. Okay, so I captured this here. I want you to read it with me. Go ahead. When we add or subtract fractions with the same denominator, we change the number of parts, not the size of the parts. This means only the numerator changes.